Gautam, I am audible?
Sir, you're audible, sir.
Okay, thank you.
Just, sir, I'm when wasn't it right, sir? So, shall we start, sir?
Yes, sir. Can start.
Yes. Anil, sir?
Yes, Gautam, we can start.
Thanks. So, namaste, good morning all. On behalf of NIDM, I am Gautam, Junior Consultant with GIS and DOC. Welcome you all to the last day of 3 days online training program on Geospatial Technologies for Disaster Management, organized by National Institute of Disaster Management in the collaboration with Bharatdas University, Tamilnadu. Before starting our last day sessions, I would like to convey my sincere thanks to Sri Taj Hasan, IPS AD, and Professor Surya Prakash Sir, Head, GEMA Division and CBRN, Industrial and Cyber DRR Division, NIDM, Ministry of Home Affairs, Government of India, Delhi, for giving this opportunity to conduct this 3 days online training program. And a special thanks to Dr. Selvam, Sir, Vice Chancellor, Bharatdas University. Without late, I will quickly recap our last 2 days sessions. On first day, Sri Ajit Vadam YP, NIDM had delivered a training session on disaster management and legal framework, followed by Professor Srinivas Raju sir, faculty at Institute of Remote Sensing. I delivered a training session on Geospatial Technology for urban flood management, a case study for Chennai metropolitan area. And also, Mr. Jayachandran sir, project director, Karnataka's State Remote Sensing Application Center, Bangalore, had also delivered a training section on role of geospatial technology in effective disaster management during pandemic period. On second day, Dr. Harjit Kaur ma'am, junior consultant from NIDM, had delivered a training session on GIS-based landslide susceptibility mapping and risk assessment, followed by Sri Harihara Kumar sir, YP from NIDM, had delivered a session on coastal hazards and DRR and R measures. And also Professor Ganpati sir from VIT had delivered a session on geospatial applications in earthquake risk reduction. Dear participants, please note that you can source your questions, inquiries in chat box and also in question and answer section. And also, please make sure that you attend and pay attention to the sessions to claim the certificates from NIDM portal, training portal after this OTP. So without late, I'd like to introduce our first speaker to our audience. Mr. Anil Kathet sir is currently working as a technical officer, emergency management, UHS CDC India. He is a postgraduate in geology with over 8.5 years of experience in the field of landslide hazard management and disaster management. Prior, he worked with some of the prestigious organizations such as NIDM, UNDP, NIUA, and CRR. He penned 20 research papers on various aspects of landslide hazard mitigation and management entirely, and contributed to drafting the engineering guidelines on landslide mitigation measures for Indian roads. With this, I'd like to invite you, sir. The floor is yours.
Thank you very much, Mr. Gautam. Let me share my screen. I hope my screen is visible.
Yes, sir.
Okay, thank you very much. So I will be talking about the landslide risk assessment and management. So, but the first thing we need to understand is that this hazards like landslides, they are part of normal process of landscape forming. As you may be knowing that our Earth, the continents of all the continents of our Earth were once combined in one super continent, Pangea, and this single continent, it slowly broke apart and spread out to form the continents we know today. So all this process, they have been occurring since the materialization of our Earth, and they shall continue to occur as a dynamic process, tectonic movements, and all these things. But here we need to understand that this naturally occurring landslide process without any human intervention, but the same process it raises higher concern when they cause life loss, when there is damage to our property, and the frequency of reoccurrence is so high that we are generally we find ourselves helpless to properly addressing the issues related to landslides. So, as you know, our country is one of the highly landslide prone nation in the world. And according to the Geological Survey of India, which is the nodal agency for landslide management, landslide study as well as management in the country, according to our nodal agency, around 12.6% of the land mass of our country is prone to landslides, different types of landslides, and the landslide vulnerable areas, they are spread over 19 odd states, as well as few 3-4 union territories, right from northern Himalayan states to our southern states to our northeastern states. So why it is that some slopes, they are susceptible, they are prone to landslides, whereas others are comparatively stable. So for that, there are many elements that play a crucial role. There are many factors that contribute to the instability of slopes, and this it includes high relief, it includes the type of drainage pattern, drainage bedrocks. It also depends upon the vegetation cover, and as well as other disasters like earthquakes or unprecedented rainfall, cloudburst. So the conditions factors are governing these landslides. They can classified as inherent or basic conditions, or external factors. External factors, like I mentioned, when there is heavy precipitation, as you know, in our country during monsoon season, you may be hearing now these days that that slope has failed. The slope failure has occurred at landslides has occurred at that part of the country due to heavy rainfalls. So apart from heavy rainfall, there is earthquake. You can take the example of Sikkim earthquake that was in year 2011. That earthquake triggered more than 100 landslides in the states of Sikkim. And as well as the human activities, the anthropogenic activities, the construction activities, in dearth of proper understanding of slope dynamics, they have also augmented the number of landslide incidences in our country. There is one more thing that is attached with the landslide hazard. It is that landslide, they are multifaceted phenomena. They have a broad spectrum of magnitude. They are different types of they can be called, like I mentioned, they can be there are many causes that can trigger landslides. Landslides can be triggered by other disaster like earthquake, like when there's floods or flash floods. They are also responsible for producing this landslides. As you can remember, during the Kedarnath tragedy of 2013, the flash floods during its course to town stream, it generated a number of this landslides. Some were reactivated. Some at some places new landslides were generated by that flash floods in 2013. And the other side of the landslide is that they are also responsible for this in for inducing this disaster like flash flood. You may be remembering the Alaknanda tragedy of 1970 that was due to the breach of landslide dammed lake. And landslide are also responsible for producing tsunami. Uh, like this submarine landslides, they are enough capable of producing huge tsunamis. For example, the Indonesian tsunami that was in year 2018. It was as a result of this submarine landslides. And climate change, as you know, this is the topic of climate change is the it is attached with every sector, and there is adverse impacts on the temperature, on the precipitation. They are enhancing the flame, the quotient of this landslide disaster, and it will be constantly challenging our future strategies, how we are going to manage the slope failures. See, nature always gives up some sign before there is any major this disasters. And likewise, there are some potential landslide risk indicators, and simple observations of this indicators or inspections of these indicators, they may assist in assessing the potential landslide hazard. By knowing which are the this potential risk indicators, we can this say whether the slope will fail in near future or not, whether there is some activities going on in the slope or not. And yeah, so as you can see in the figure, there are so many indicators that can depict that the slope is stable or not, like saturated ground or seepage in area that are not typically wet, or you find new cracks or scarps, or you see any unusual bulge in ground, or this road pavement, or when you this find the tilting or cracking of the concrete floors or the foundations, or broken water lines or other underground this utilities, or leaning of this telephone or electric pole, or leaning of trees, or any this like retaining walls or fences. So all these are some of the indicators that the slope there is the slope is active. There's some activities going on the slopes, and there are chances that in future these slopes can fail. When we talk about the impacts of landslides, so it can be classified as direct landslide as and indirect landslides. And direct landslides are those first order consequences which occur during and immediate after an event. For example, when there is any death due to landslides, or there is damage to our any infrastructure or structure. So they are the direct impact of landslides. And when you talk about the indirect one, the indirect, they may emerge after the landslide event, and maybe more or less they are easy to attribute directly to landslides, like when we have psychosocial impacts of landslides, or when we have to evacuate our land due to landslides. Uh, So I will just share an example of this Kalyasar landslide. Many of you may be knowing, may hear the name of this landslide. It is on the National Highway 58 of Uttarakhand state, and it is one of the notorious landslides. It was first initiated in year 1920. And since then, it has been a major concern at this particular highway. So when I was working with Central Road Research Institute, we carry out a study to estimate the cost of indirect losses due to this, due to landslides. As you can see, this peak is from June 2010, and this one is in October 2010. During after the monsoon, this in 2010, this landslide was deactivated, and it was this particular road was blocked for more than 40 to 45 days. So due to closure of this particular highway, National Highway 58 at Kalyasar, at this point at Kalyasar landslides. So travels were forced to detour, and we calculated the total detouring cost for 45 days, and it was more than 2.5 million rupees. And this indirect loss of this, it was only of detouring, and it is still a low estimate. At it does not include other business consequences from the loss of access to local uh, resources and associated loss to the business of local shops, business to local restaurants, hotels, tourist sites. So coming to the landslide investigation, the investigation and this characterization of this surface as well as surface condition from they form the core of landslide studies, and the success of our mitigation, our management of landslide agent of any landslide, they depend upon the quality of investigation that is carried out on that particular landslide site. And the this evaluation of terrain, we have a number of investigation methods, techniques available for landslides. The evaluation of this terrain through investigation, it will lead to predict the problem which may likely to occur, or consequently suitable remedial measures, suitable plans for mitigation or for management of identified trouble areas. They can be taken up. And investigation, it has different phases, like preliminary investigation, and the purpose of this preliminary investigation is to establish the geological, geotechnical feasibility of the site, and to determine the extent or precision of detailed this surface investigation. It is required to obtain information that is needed to design or to construct this control or preventive measures. And then there is a detailed field investigation and mapping, and this field investigation, this is the central part of this landslide, the study of landslides. So with an approximate understanding of the overall topographic features, overall knowledge of the distinction of the movement, the extent of the sliding blocks, or detailed field investigation, we can develop a plan to delineate the aerial extent and a general direction of the movement of this landslide zone. So detailed field investigation plan, it can be drafted to delineate what type of landslide is, what is the size of landslide, and what is mechanism of it. What is the nature of that particular landslides, and what are the possibility of future movement on that particular slopes. So this is the basic framework for risk mapping. Starting from this landslide inventory and database. The landslide, this database and inventory, it is an important, and in fact, and database and inventory is the first step towards not only the landslide hazard mapping or risk assessment, but also towards any of landslide hazard mitigation and management program. And the inventory of landslide before donation, it is prerequisite because an area it can be said prone to landslide when the terrain conditions that are they are comparable to those where already a slide has occurred. Sorry. Basically, this landslide inventory maps, it shows the distribution of past and active landslides and their relative activity level. What is the land? What also depicts the landslide density, geomorphic attributes within an area. And after this landslide inventory, there is landslide sustainability mapping that usually involves developing an inventory of landslide which have occurred in past, together with an assessment of this area with a potential to experience landsliding in future. But we have to remember that in this substability mapping, there is no assessment of the frequency, that is the annual probability of occurrence of landslides. This substability mapping, it involves the rating of the terrain units according to the the probability of the probability to produce landslides, and this is dependent on the topography, geology. It also depends on the technical properties, vegetation, climate, as well as the anthropogenic factors. And the scale, when you talk about the scale of sustainability, it is usually a relative one. These maps are prepared to locate, identify the area that are susceptible to future stability problems, and the landslide hazard mapping. Landslide hazard mapping, it is a step further of this landslide susceptibility mapping, and the technique used in this hazard mapping, it take into consideration the knowledge of past events, what are the present conditions prevailing in the area, and the anticipation of the future behavior of that particular slope. So the hazard may be expressed. It may be expressed as the frequency of a particular type of landslides of a certain volume, or the landslides of a particular type, or this volume and velocity. And risk mapping, it takes the outcome of hazard mapping, assess the potential damage, what will be the potential damage to a person or to the this property, that are the element at risk. This is the framework for management, landslide risk management. Gather accurate landslide. For that, we need to have accurate landslide hazard information, identifying landslide prone areas and plotting them on planning maps. That is essential for communication, for communicating the risk that are present, and mitigating such hazards. So basically, we need to plan to avoid landslide hazard before any any development activities. And landslide hazard can be avoided by preventing development on known landslide hazard areas. We should avoid for any this construction activities at landslide prone areas they are already susceptible to landslides. And when if the where avoidance is not possible, we have to adopt mitigation measures. Mitigation measures can be applied so that we can reduce the risk through appropriate engineering works, basically we need to take a risk-based approach in areas that are already developed, or we have to planning for land use in landslide prone areas. It will help to avoid to mitigate the increased risk from a landslide hazard that is caused by basically by land use intensification. And one of the most difficult problem concerning this landslide hazard is dealing with the exiting urban areas where buildings, highways, they are constructed on or they are close to landslides. So the ideal approach in this situation is to avoid further development in high landslide risk prone areas and limit exiting this rights to rebuild at such places. Instrumentation, monitoring, early warning, this basically they empower us, they empower the individuals, they empower the communities to respond timely and appropriately to the hazards in order to reduce the risk of death, injury, or this risk of property loss. So there are a number of instruments that can be used to monitor the slopes, like inclinometer, that is for monitoring lateral movement. We have piezometer for monitoring ground water levels. We have borehole extensions monitoring of movement inside a slope. And apart from this, latest technologies, remote sensing, GIS, they have been also deployed, utilized for the monitoring of the slopes. So this is a brief list of the remedial measures for any unstable slopes. And we have to remember that the key of successful landslide management strategy is to design workable and economically viable schemes of mitigation and preventive measures. And this promotion of innovative modern technologies based on proven workability becomes unavoidable choice. And as you know, the thumb rule is that the slope failure occurs due to imbalance when there is imbalance between a driving and resisting force of slopes under the effect of gravitational force. But the triggering factors which cause such imbalance, they are different sites of landslides. They greatly depend upon the local conditions. Hence, this hazard is so varied. The landslide, it is so varied in types and size. So it is essential to identify potential hazardous slopes and control their instability by providing suitable remedial measures. And for this prevention, remediation of consequences of landslides, there are a number of effective remedial measures which can avoid they can minimize, at least minimize the adverse effects or risk of the landslides. So the slopes can be stabilized by a single method, or we can use concomitant methods of preventions. It totally depends on this the use of remedial measures. Totally depends upon the nature. What is the nature? What is the size? What is the location? And what are the triggering causative factors of that particular landslides? And this effectiveness, durability of remedial measures, to a large extent they depend upon the quality, like I also mentioned earlier. It depends on the quality of investigation that is carried out to identify the correct problematic factors of the landslide at a particular site. Now I will be talking about, like I mentioned earlier, that our nation is one of the highly prone landslide zone in the world. So what endeavors, what interventions our country has taken to manage the landslides. So in this series, first comes this high power committee in 1999. and it focus on to clutch the learning of past disaster in India and as well as the outside the country. So this committee was constituted to endeavor to provide a new conceptual framework to minimize the impact of disaster. And this committee also classified different disasters into 5 different categories, and landslide, and they placed landslide under the geological rated disaster groups. And the committee highlight in its recommendation, the committee was formed in 1999, and their recommendation were out in year 2001. So the committee highlighted that landslide, they are we can predict them, they are predictable, and the adverse impacts posed by them, they can be minimized, or they can even averted when there is proper and systematic studies of the landslides. And this committee has given priorities. They given priorities to landslide hazard identification. They also exhorted on improving the landslide mapping assessment to identify the exiting potential slow failures, and deployment of reliable risk assessment, as well as they also focus on the sensitization of the community. So in year sorry 2009, apprehending this the enormous destructive potential of the landslides and the need of reducing the resultant losses of lives to damage to the property, our national authority, they come up with guidelines on management of landslides and snow avalanche in year 2009. And basically these guidelines, they incorporated time-bound regulatory and non-regulatory framework to institutionalize the landslide hazard mitigation efforts, apart from enhancing the capacity of our society to take the appropriate measures to avoid or reduce the risk and costs that are associated with this landslide hazard. And in year 2019, our national authority come up with this. They formulated a national landslide risk management strategies in 2019 to address all the challenges of the landslides, not only on national but also as at the local level. And this study, it also accomplished the 5th target of Sendai framework for DRR, that is the substantially increase the number of countries with national and local disaster risk reduction strategies. And this strategies is lay a recommendation on all major components of landslide disaster risk reduction and management. And the major components, this landslide strategy, it focus it includes landslide hazard mapping, monitoring, and early warning systems. It also talk about to foster the awareness generation, capacity building and training, and also the mountain tour regulations, policies, and mitigation of landslide, and creation of a special purpose vehicle for this landslide management. So a number of recommendations were laid by this strategies, and it also talk about that to produce maps at macro and meso scales using advanced scientific state-of-art tools. It also talk about to promote the culture of awareness generation, preparedness by involving by educating the local communities, especially our youth, about the landslide management, as well as other hazards of depending upon their geographical areas, as well as this Also, this guideline also talk to review and to revise whatever the existing codes are there, whatever the existing guidelines or for landslide management are there, and to update them. So a number of initiatives were taken at a national level to mitigate this problem, this landslide hazard. So a number of departments, number of institutes, they are working in the field of landslide risk reduction and resilience in our country, like Geological Survey of India, which is under the Ministry of Mines. It is associated with landslides since 1880. And this GSI, it was declared as a nodal agency for undertaking the research on landslides management in year 2004. And apart from that, a technical advisory committee was also constituted for landslide mitigation and management, and to foster the landslide related research and development in the field of mapping, in the field of monitoring, as well as capacity enhancement. And in year 2014, the nodal agency for landslide, they launched national landslide sustainability mapping program to cover to cover the landslide prone areas of our country and to create a dynamic national landslide sustainability geodatabase. And apart from these nodal agencies, there are other agencies like Bureau of Indian Standards that publish a number of codes, guidelines related to different features of landslides, such as landslide hazard, zonation mapping, design, as well as constructions of various structures for landslide control. Then there is Indian Road Congress, IRC, which help the stakeholders concerning landslides. It basically focus on the highways, on the roads through their guidelines. And we also have a Building Material Technological Promotion Council that is under Ministry of Housing and Urban Affairs. That is in year 2019, they come up with the third edition of Vulnerability Atlas of India. So I would like to conclude here by saying that we need to synchronize our activities with the attribute of slopes where we are living. We have to understand the health of slope. We need to enhance our understanding of the slopes before we are taking any construction activities in any kind of slope. So we need to make this disaster risk reduction a part of our regular curriculum. We also need to enhance the capacity of our communities, which is a crucial element, as our Honorable Prime Minister in his 10-point agenda on disaster risk management, he also highlighted the need to build local capacities, local initiatives, and the people should also trained when, what, and how they should respond to minimize the risk of not only the landslide but other disaster as well. And our focus should be on developing a culture of safety, a culture of resilience to avoid avoid or minimize the risk of disasters like landslides. So with this, thank you very much, and I'm back to the host.
Thank you so much for taking time for us to deliver a training session on landslide risk assessment and management, sir. Sir, as of now, there is no questions. Hello.
Hello.
Sir,
Yes.
as of now, there's no question from audience.
Okay.
So,
If there will be any, you can share with me through mail or any
sure,
other.
sir. So on behalf of
Okay.
NIDM and Bharadas University and participants, I could like to convey my sincere thanks to you for taking time for us today.
Thank you. Thank you very much, Mr. Gautam, for inviting me and
So,
providing me this opportunity. Thank you very much.
thank you so much, sir. So we are moving to our second technical session. I'd like to introduce our second speaker to our audience. Dr. Muthu Shankar, sir, is a researcher and head of GIS projects at Department of Geospatial Monitoring and Information Technology, French Institute of Pondicherry. He has nearly 20 years of experience in research in the field of remote sensing and GIS for environmental monitoring. He has published more than 50 papers in reputed journals. His research area mainly focused on assessing environmental risks and vulnerabilities to climate-related natural hazards, climate change, and sea level rise, oceanic forces, and anthropogenic effects using spatial observations and field data. He has completed graduate and PhD from Bharadasan University, Tiruchirappalli, India. With this, I'd like to invite Muthu Shekaran, sir.
Thank you. Thank you, Gautam. May I audible?
Yes, sir.
Thank you. Good morning to all. First of all, thanks to NIDM team and Professor Lakshman also. Okay. Please, sir, giving the permission to share my screen. Gautam?
Yes, sir. I give one, sir. I give one.
Okay. Yeah. Now is my screen is per second. So my screen is visible?
Yes, sir.
Visible. Okay.
Yeah. Thank you. Yeah. In this training session, Geospatial Technology for Disaster Management, today I am planning to take the cyclone vulnerability mapping for Tamilnadu state. Okay, in this slide, yeah, on the left hand side, the Thane cyclone. I am showing the Thane cyclone, the 2011, 30th December. Actually, early morning crossed in our city, Pondicherry. Yeah, this is our institute. Center photo is our institute. The next day morning photo. So nearly the third photo is showing the cloud cover of the rainfall cloud. So nearly we received 25 centimeter rainfall that event. Okay, like that. I'm sharing with first. Yeah, 1 second. Yeah, but I want to share the first slide to the world level cyclone impacts. If we see the first one, the entire world from 1980 to 2009, so the entire world frequency of the region based on the region. So the orange color is showing the Western Pacific, nearly 45. The red color, 37, is the region of the Americans. So here, our Southeast Asia region, nearly 9% here. But coming to the death by region, we are 80%. The same time affected the population region 53. So what meaning we are, of course, we have the population density is more for the Southeast Asia region. Next is saying our preparedness and mitigation is still we are lacking. So for that we need for the good hazard mapping and vulnerability mapping of our area. So coming to one by one, we will see. For the Indian category of the cyclone disturbance, we are categorized from depression to super cyclonic storm. This is available from the IMD. Our IMD categorized from depression, deep depression, cyclone storm, severe cyclone storm, very severe cyclone storm, extremely severe cyclone storm, and super cyclone storms. So different category based on that one. There is a wind also, wind speed also it will change. So if it cyclone storm from 60 to 80, severe cyclone storm 87 to 117 km per hour. Either same wave height also it will change. So this data is available from the IMD website, from IMD cyclone site. Okay, next from the intensity damage expected. For example, depression, it's a minor damage only to loose and unsecure structures only. The same with the cyclone storm, damage to thatch huts and breaking tree branches causing minor damages. So like that, there is that intensity damage expected is there. If you see the extreme severe cyclone, extensive damage to Kucha houses, some damage to old buildings, large scale disturbance power and communication lines, disturbance railroad traffic. So the major what are the structures will damage is expected based on the intensity. Just then the super cyclone. Yeah, we received that to the 1999 in Orissa super cyclone. So based on that one, is the damages are showing here. Okay. Just this is for your idea, you know, because this is all the information you will get it from the IMD website. Then coming to the cyclone impacts. The cyclone impacts major causes for the damage, destruction of loss of lives based on storm surge and coastal flooding. Then heavy rainfall in inland flooding. High sustained winds is the major cause. Storm surge, heavy rainfall, wind and gusts. If we taking the storm surge, what are the effects it will come? Flooding in the coastal area, then erosion of the beach. Already erosion is happening in the natural or man-made anthropogenic. Apart from the storm surge time, erosion of the beach is the storm surge. Then saline water intrusion because of the storm surge. Then damage to the structures. These are the effects of storm surge. Then heavy rainfall. Because of the rainfall, it's within a day 25 centimeter, you know, because Thane, I already told, we received nearly 30th of the December. The next day we received 10 centimeter. Totally 25 centimeters rainfall within 2 days we received. So it's triggering the flood. Then damage of the crop and livestock. The loss of life. Then the third, wind. Wind also is, for example, Thane, we received nearly 120 to 130 kilometer speed wind is we received. Like that depends upon the cyclones, the intensity from the 62 up to 150, 160 we are receiving in India. Damage to structures, including power and communications cables, then loss of life. Lastly, destruction of crops, vegetation, and livestock, heavy rainfall also. So this is the major impact from storm surge, wind, and rainfall. So based on that, we are planned to entire Tamilnadu coast. So by vulnerability atlas indices. So here we are taking one side is the physical vulnerability index, then another side is socioeconomic threat index. Physical vulnerability index from the cyclone frequency and intensity. The first cyclone frequency and intensity, then probable of maximum winds per the district, probable of maximum storm surge from per district, then the probable maximum precipitation (PMP). Then the last erosion, you know, because erosion already happening in the coastlines, maybe the natural or anthropogenic. So this is already a vulnerable place. Again, because of the cyclone storm surge, more vulnerable to that place also. So we are taking the physical vulnerability in the 5 indicators to take for physical vulnerability. Coming to the socio-economic threat index, population density, the first overall population density. Then the child population. Always child is a very vulnerable child population. Then fisher population. They are in front of the beach peoples. So they are affecting both ways of their houses property wise plus human loss, their fisher populations, both land and water, sea. Then house types. That means is the Paka concrete house or the apart from the concrete houses like Kucha house, huts or Tachi house, we are taking because they are more vulnerable. We saw in their because of the effects that people only affecting more, because the concrete people houses is less affect only. So that's why we taken that also. Then Finally, agricultural land. Because of the flood and the storm surge, it's unletting the water, this agricultural land. There is loss of that loss also. So we taken the socioeconomic threat, 5 indicators. So all the variables, we take an index value, create actual value minus minimum value into 100, maximum value minus minimum value we used in this one. So using, so coming to first cyclone, yeah. For the cyclone vulnerability index, nearly cyclone is 1991 to 2020. We received total cyclone is total number is one, the 101. In this one, depression and deep depression is 41. Cyclone is 25, and severe cyclone is 35. Okay, 1 second. So we received in the last 120 years, say 101 cyclones. Deep depression is 41, cyclone is 25, severe cyclone 35. This data is taken from the IMD EA Cyclone Atlas. From Atlas, we taken all these things. Next, based on the intensity, we made the vulnerability index. If it is a deep depression, we take the 20 kilometer buffer. That means along the track 2020, 40 kilometers with deep depression affecting area. Then cyclone, 40 kilometers, both sides. That means 80 kilometers. We given the weightage for the 20. So for the deep depression 10, cyclone, we given the 20 weightage. Then severe cyclone. For the area wise, we taken 60 kilometers buffer. So both side is 120 kilometers. Total 120 kilometers for the from the track. This side 60, that side 60. Both side we taken. This side 60, then 6 side 60. So weightage we given 30 weightage rank. So the final vulnerability map index here. So Kadalur and Pondicherry area is falling in the very high vulnerability index is falling in this one. Then and the high is 460, it's Navapatnam area is falling. Like that, we are created for based on the cyclone intensity and frequency vulnerability index mapping. This information we transfer to, this is the index value, we transfer to up to district level we transferred. Okay. We transfer the district level. So here is say the right left hand panel is the data. The right panel we transfer the data to the district level. So here the dark brown is falling the very high Pondicherry and Viluppuram Kadalur area. It's falling in the high vulnerability area. It's for cyclone vulnerability index. Then we taken the probable of maximum winds. This data is available from the IMD Atlas, Cyclone Atlas is there. Same time, there is a paper is from the IMD people published the paper. Classification of cyclone hazard prone district of India, entire district is there, it's available. So district wise, they having the probable maximum winds, rainfall, and storm surge is there. So we are taking that one. Left hand side is the raw data, wind speed from 39 to 50 we are receiving in Tamil Nadu. So here right side is based on that vulnerability cyclone wind vulnerability index. So right side all the very high is the high vulnerability index, nearly 48 to 50 knots wind speed we are receiving in this region. So based on the wind speed, probable maximum wind speed. The next we taken probable maximum precipitation within the cyclone time. So we are getting the rainfall from 42, it's possible rainfall. Probable maximum rainfall 42 up to 68. So yeah, this zone, the dark brown zone, we are at nearly 60 to 68% rainfall is possible. So based on that, we are create the index. Index in this right side is from low, medium, high, very high regions we classified based on that one. Okay. Then probable maximum storm surge area. So storm surge is possible because we take taken inside the, because this, I didn't forget to tell them. We have taken the coastal district, then close to coastal district also. Maximum 100-meter kilometer width we have taken for this study, in this study. Okay. That adjacent district, nil storm surge vulnerability index. Same time, from 3.51 to 3.5 to 12-meter possible storm surges here. Particularly in the Ramanapuram district, Rameshwaram, this region is the 12-meter storm surge is possible storm surge. So based on that, we have created a storm surge vulnerability index also. Then I already told the erosion area. Already it's erosion happening in the entire coastline. So the report of the NCCR report have 2018, they published entire India district-wise shoreline changes is available. We are taking that data. So district-wise data we used for that one. So we have the table. Each district, how much is high erosion, moderate length, kilometer length, moderate erosion, low erosion, then aggregation, all is it's there. So we taking district wise, all the erosion is the three: high erosion, moderate erosion, low erosion. We taking that one. So coastal eroding on that particular district, we taken for that also for the coastal erosion index. So based on that one, we have created the coastline erosion. It's erosion actual value percentage is that percentage value. So here it's the erosion vulnerability index. We are created from that from the this one. So like that, we have created all the 5 physical vulnerability. This is the overall physical vulnerability index. It's the cumulative of all the all 5 from I already told physical cyclone vulnerability index, intensity and frequency, then storm surge, then flood, rainfall, then the wind plus erosion. All we have taken total physical vulnerability, overall physical vulnerability. Then because not only because our socio-economic also is the important role for the vulnerability in this one disaster. So here we are taking the population density. So Chennai is the high population density. Then the Pondicherry, Karaikal, this is Kanyakumari. So these all are high density population districts. Is one. So based on that one, we create the vulnerability index, population density index. Then the next highly vulnerable population-wise, child population. So child population, we utilize the child population based on the percentage here. Here is Viluppuram, it's high child population area. So based on that, we have created a child population vulnerability index also. Then fisher population, because they are the ultimately affected peoples. Because they're affected in the land side plus the seaside also. For the example, Oki cyclone, they are affected nearly in Tamilnadu. 130 people died in this one. In the Oki, fishermen died in. So we are considered that also fishermen population each district wise. So if you're taking the Tamil Nadu, Ramanapuram district and Kanyakumari, it's the percentage of the fisher population we taken or overall population. Then in that fisher population, how much? That only we taken this one. So Ramanapuram, Kanyakumari, and Karaikal is the highly fishermen population is there. Based on that population percentage, we created the fisher population vulnerability index also. This data from the CMFRI, Marine Fisheries Census 2010, the 2005, 2010 and 15 also now it's available, but we have taken this 2010 data, CMFRI data, census data. And then agricultural land, because of the storm surge plus flood, because the agricultural land like close to the coastal district, all the agricultural land submerged by the water, because water. That's why we taken the economic loss. We taken the agricultural land also. This data from the Directorate of Economic Statistics is available each district wise how much land area, agricultural land area. Based on that one, overall land surface with percentage of the land surface we taken, we are making, of course, this is the Kaveri Delta area, highly agricultural land. This dark, very high area. It's Kaveri Delta region. So fully and full agricultural land. Then coming to already I told the non-concrete house apart from non-concrete house, because in the most affected people is the hut and thatched house. Non-permanent house people are only affecting the because of wind and flood, wind and more rainfall, storm surge also. So based on that, we have taken. This data is available from the census 2011. So you see all the brown, very high region. See most of the wherever the agricultural land more, that side only the non-concrete houses also is there. Okay, so it's showing the agricultural poverty also. See this one. Okay. Then overall socioeconomic vulnerability index here. We take all the population density, then child population, then fisher population, agricultural land, and finally house types. All the taken from for the socio vulnerability index. So we created. Then we merged both two, physical and socio-economic vulnerability index. So these are the nearly three districts. Particularly Viluppuram, Kadalur, Nagapattinam falling in this high vulnerable zone. At the same time, Thiruvarur and Kanchipuram, the next level, high level. So based on this parameter, we are created the physical and social vulnerability in the state level. Then what I did, I taken only Kadalur district for the village level, because we need to next level, village level. So the assessment of the physical and socio-economic vulnerability at the Kadalur district village level we did. The same, we have taken the same cyclone, sea level rise, storm stretch, flood area, prone areas, erosion, coastal fire. This one is where worked detailed one. I'll show you this one. Then the socio-economic threat, village level population density, infrastructure, house types, agriculture, aquaculture. Here we use the remote sensing data also for the deriving all the things. So finally, we created a cyclone vulnerability index up to the village level. Same index value, UNDP index value only we used for this work. Okay. So yeah. First, taking up to the census village level, the cyclone strikes last 100 years. Once this is the left side is showing. Based on that one, we created the vulnerable village vulnerability levels from low to high level within the district. Within the district, we created. Then the coastal erosion using the 2003 and Google Earth image. Because a very high resolution image, we taken very high resolution 2003 and 2019 data. So here see the red color is showing the erosion area. Green color it's aggregation area. Red color more is erosion area. So based on that one, we are villages we created the erosion prone area, prone villages. This is high erosion prone area villages vision. The next coastal flood. Because already I told here the storm surge is possible 3.5 meter in the Kadalur district. So we taken from the elevation model, so digital surface model only. Based on that one, we created inundation is possible up to 3.5 meter. We taken the flooding possible, because this district is totally flat area only. There is no flat one. So this much level is possible to the coastal flood. Then based on that coastal flood, we transfer to the village level. Is that vulnerability index in this one. Then settlement distance from the shoreline. They're very close to the shoreline. They are very vulnerable for the storm surge. So that also we taken, because the very high resolution, it's possible is hamlet wise is mapping is possible. So we did that each hamlet village habitation wise we did the mapping based on that one, how much distance from the shoreline also we taken. So we transferred all the to the village level, the census village level. So the final overall physical vulnerability index of this region. Then the same social taken, economic vulnerability index we created based on the population vulnerability index. We taken from 2011 up to village census, because the boundary is census village only we taken. So census village wise the population density and then built up area. This is from the interpretation from the satellite image, Google Earth image. Built up area means here is the industrial area plus residence area we mapped from the Google Earth falling inside. So this all are in a residence area. Here is the industrial area. So here is two Sipcot industry areas there here. So this is a built-up area, both habitation plus industrial. So based on that one, we created vulnerability indexing at village level. Then house types. I already told house types. Apart from other than concrete houses, we taken. So this is a village level within the Kadalur district coastal village. We taken this one. Then agricultural land and plantations, aquaculture also, because it's directly it's the economic loss because of the storm surge plus flood also. So we mapped from the Google Earth or where agricultural plantation aquaculture area we mapped here. It's a very high resolution using the very high resolution satellite image. So plot every single plot wise we mapped. So we transferred the data to the village level. So these are the villages are dark, very high vulnerable area. So the final overall socio vulnerability index we made from that from the agricultural plantation aquaculture index. So this is overall. Then overall socio vulnerability. So the last slide is showing the overall socioeconomic vulnerability index. So we merged with physical and socio-economic in this one. So these are the villages, or nearly down at 8 villages are highly vulnerable one. So we, according that, we need to plan preparedness and mitigations. These are the villages that are highly vulnerable to the cyclone. So we need to give more priority for these villages. This type of the vulnerability map, hazard map, is more useful for the policymakers and the administrators, government administrators useful, okay, to give the more priority for the cyclone vulnerable this one mitigation purpose. So yeah, these are the villages are falling. These fishermen villages are falling in this different vulnerable areas. Then these 5 villages are more vulnerable to the coastal erosion. Then if with the cyclone come, more vulnerable people. These 5 villages peoples. Okay. So yeah, this overall vulnerability mapping. Coming to the I give just one mitigation and preparedness measure for the cyclone. We are planned to very high hazard mapping. This hazard mapping is very high resolution level using the DTM of LIDAR data, because centimeter accuracy of the elevation model to utilize for this hazard mapping plus high resolution up to plot level. Then only it's good for the hazard mapping. Presently, we are not having that like that. So if we use that type of the information, it's useful. Then the land use planning also. According that hazard map, we need to plan land use planning. Then engineered structures also. Because I already told, as we know, after the Thane, we visit the field work. Then after the Gaja, we visit the field work. The problem is communication. All the electrical lines and transforms totally damaged. Then the communication towers also. So according that, we need to, because most of the coastal area, we plan to underground cable, EB line structures like that. Then the building structures also. Then already I told, most of the if it's the Prime Minister fund or this one, the new housing to change the hut to a permanent house, concrete house, because this region more the huts is there. So convert to huts to permanent house, little bit reduce the mitigation, reduce the vulnerable for this one. Then cyclone shelter, every village to make a cyclone shelter. to create this one. Then the flood management, because we need to good storms, because we receive the rainfall within a day, 20 centimeter to 25 centimeter. We experienced nearly 30 centimeter also. 2014, we received nearly 32 centimeter. Kadalur district received 32 centimeter per day. So we need to, because entire area also flat, the very coastal area flat. So we need to good flood management system unit. Then mangrove plantation. It's a natural ecosystem. It's prevent the area is one. Like we have the Pichavaram mangroves and weather name also we have the mangrove plantation. So wherever possible we can. There is now the new gray and green solutions also is there. I will explain to the next slide. Wherever possible, we can incorporate gray and green solutions. It's useful for the future climate sea level rise and for this type of the natural calamity also, for the cyclone also. Then the important public awareness generation. This is more need public awareness generation. If it because in my institute is just in front of the beach. If he wants the cyclone any come, the most of the people are coming to watch the sea only. There are a lot of people are coming in this one. So we need to give the because we need to give the people awareness generation also. Then end-to-end warning system. Now is warning system. Paka is the IMD is doing well. Little bit some because we failure in the Oki cyclone also. Apart from we are doing well in this one. So end-to-end warning system. Then community participation. This is very important to create the community participation because any community is the first attending people, participant people only first attender. All other agencies are coming after later only. So community participation strengthening, it's a very, very important to up to village level for the mitigation and preparedness for the cyclone. Okay. Finally, I just touched the green-gray solution. The new one green-gray solution is the recommended one. So wherever possible to create the green infrastructure mangrove with small breakwaters using the traditional embankment, traditional one, putting in the stones and one. So in front, if we put it in this gray solution, gray structure solution, if it's sediment accumulation, then if it's possible to create the mangroves or mangroves one. So green-gray solutions. This is So now is the recommended by the World Bank. This is the This photo is photo is in the Philippines. Already the Conservation International NGO international organization did in the Philippines 5 villages. So from that only. Okay, it's a little bit helpful for to reduce the cyclone wave in the intensity also. So here from thank you. Thank you.
Sir, thank you, sir. Thank you so much for taking time for to deliver your training session on cyclone vulnerability mapping for Tamilnadu coast.
Welcome both. Any questions?
Yeah, I'm checking, sir. There's no questions, sir, in the audience. Sir, on behalf of NIDM and Bharatdas University and participants, I could like to convey my sincere thanks to you for taking time for us.
Thank you, Gautam. Thank you, Professor Lakshmana.
Thank you, Dr. Muthushankar, for your nice presentation. Thank you very much.
So, participants, we are moving to our third technical session. So, I'd like to introduce our third speaker to our audience, Dr. D. Kumaran Raju, sir, Principal Scientist, National Technology for Ports, Waterways and Coast, Indian Institute of Technology, Madras, Chennai. He is a scientific researcher with more than 25 years of rich experience gathered through a variety of academic and scientific and operational research projects. Lead researcher and investigator, actively involved for the past 6 years on the climate change impact studies, natural disaster risk assessment and management using EVO and geospatial technology. He is actively involved for past 10 years in various capacities on developing smart and innovative maritime applications, environmental sensing and data analytics for ports and defense sector. His area of interest are Earth observations for marine environmental sensing, monitoring and management, and also smart and innovative methods for hydrographic surveys and environmental monitoring, etc. With this, I like to invite you, sir. The floor is yours.
Good afternoon to you all. Thanks, Gautam, for the introduction. And I think in order to proceed further, I think I need to share the content. It is not showing me. Can you give me permission for the... Okay, thank you.
So now you got it, sir.
Yeah, thank you. Thank you. Is the slides visible?
Yes, sir.
Okay.
Yes, sir.
Yeah. Once again, thanks for that introduction, Gautam, and thanks, Professor Lakshmanan, for this invitation. And today, actually, I'm trying to discuss with you all on one of the aspects which we had carried out as a part of vulnerability and assessment study in Singapore, which leads to an adaptation study as well. How geospatial technologies help in developing such type of solutions, which includes hazards as well as on risk, and how coastal land use also can be planned. So I hope this presentation will be of interest to you all on how this methodologies, because it is not possible to compare Singapore and India, but at least the methodologies and how we can able to look into the what you call adaptation techniques. That is the main idea I'm trying to figure it out here. Okay, so with this brief introduction, I'm trying to get in there with the introduction about coastal zone. So most of you likes a lot whenever you get into a beach, and that is where the place it's all happening. So any coastal development, whether it is residential, industrial, or commercial use, there is a lot of attraction towards when you look into coastal zone development. So all those things are quite what you call very attractive, and it is being a point of attraction for such development. So when we are looking at coastal zone, we also need to look into some facts and figures. And based on IPCC, since we are talking about climate change, so Intergovernmental Panel for Climate Change has some statistics. That is what I'm trying to present here in terms of urbanization. 37% of the world population lives within 100 kilometers of the coastline. And in many places, population growth is double the national average when it goes to the coastal areas. And 23 cities are expected to have more than 15 million inhabitants by 2025, which is not very far. And 18 of these are coastal. And most of the coastal mega cities are concentrated in developing countries. This is something like I'm trying to highlight, so that we are near to the coast and how we can able to plan our what you call assets. That is the main idea here. So climate change, I'm not going to get into technicalities of the climate change. So one is natural variability, another one is anthropogenic climate change. So which expedites the what you call the changes in the climate, and that is where we look into multiple sectors, and mostly it is like the most affected is in the developing countries, because there are many factors for it. And when you look into very carefully, all those things have an impact on freshwater resources, food supply, human health, and coastal zones. So so we already have this earmarked by the a team of people, and then that is where we need to look into how coastal zone can be protected. So this study, the present study, which I'm going to demonstrate to you all, was carried out between 2008 to 2012. And after that, there was an adaptation study until 2014. So we used assessment report 4, which was published in 2007. So you can see in my right side of the slide, there are three scenarios which shows about different what you call severities of the scenarios, which ranges from B2 to A1B. And the same thing now, it was revisited and revised in 2014, and the scenarios names are changed to RCP, which stands for Representative Concentration Pathways. So I wanted to put everything in a very simple form in order for you to understand that how this best case scenarios and worst case scenarios being defined. In this case, like for example, B2, which is the best case, is like intermediate population and economic growth. That means how we have our population controlled and also how the economy. If everything goes hand in hand, and that is considered as the best case scenario. And A1, which is the worst case scenario, where do nothing scenario, everything goes on its own, and there is no what you call control or perfect this thing, and that is where the worst case scenario. So everything goes to the peak. And what will be the what you called impact on of climate change onto our Earth. So this is what is the scenarios being defined by IPCC. So further, it was defined in the RCPs, where it has a different form, and based on the emission scenarios, the sea level rise is also defined, which I will take it up in the later slides. So when we are looking into effects, which is the biogeophysical effects of climate change, one is global sea level. If it is positive, then definitely there is an inundation, displacement of wetlands and coastal erosion, increase in storm flooding, salinization, rising in water table. All those things is impact factor. The same thing like seawater temperature, if it is positive, then that is where we have the increase in coral bleaching, algal blooms, migration of coastal species, all those things, there will be an impact. I'm talking about in the global scenario. Then precipitation intensity, if there is an increase, that means if it is positive, and that is where increase in rainfall and increased flood risk. So this is the factor which we are going to talk about further on to it. So accelerated sea level rise, as I mentioned earlier, this study was carried out between 2008 to 2012. And that is where we considered the scenarios which is on the top right of the slides. And below is the new revised one. And currently the study is being revised as well based on the new projection scenarios. So in general, when we talk about what scientists say is, and it is like between the sea level rise is between 9 to 88 centimeter, which is expected in 2100. And whatever predicted is 2.2 to 4.4 times of the 20th century observations. So again, this is the predictions. And another thing is like how the regional variation works. So though there are places where there is a rise in sea level, but there are also what you called land subsidence and also places where there are retreat of sea level. So all these things is a combined effect, and we need to look into the what you call combined effect of induced rainfall induced flooding, as well as sea level rise based flooding and storm based flooding. All those things to put together, that is where the impact that we can able to measure, and that is where the planning goes in, like our adaptation measures goes in. So I'm defining this as a scenario. It's like a cross profile where you can see this is the current mean sea level, and we have what you call return periods. So once in a year, what will be the level of water, and 10 years, 100 years, and 1,000 years. Amsterdam and other European countries, they are looking at even 100,000 years return periods, so that they can plan the best in terms of the coastal settlements. So this is one of the what you call schematic which I can able to represent here. So based on that, we can derive our scenarios as well. So looking at a vulnerability assessment, how the coastal flood is being determined, like a typical scenario where you can able to see what is the current position. One is the lowest sea level, which is the tide level, and then we have the mean sea level, and then the highest astronomical tide. So this currently the landforms which are submerged with the water level is during the highest astronomical tide. Then anything above on top will be considered as the inundation. So in this case, what we had calculated based on the different IPCC scenarios during 2008-2012 is different water levels and what is the level of inundation and what is the impact onto the land use and what is the cost factor for it, which is the risk factor for it. So let me take you all further on to the next slides on the study. So it is called the Vulnerability Assessment Study for Singapore. So what we had done is typical characteristics of coastal areas like coastline, coastal type, and the other part is why I taken Singapore as a case study is there also land reclamation was very common and very popular. And while claiming the land, what is the impact of the sea level? So that they will be continuously losing the land, which has a cost for it. Okay. And the terrain, how the terrain characteristics, and how this areas which are vulnerable for erosion and inundation need to be managed. Then the sensitive land use patterns, and how the long term, in terms of long term managing erosion and inundation patterns. So I'm sure you all might have visited, and then you might have heard about Singapore, where it is and all. Just to give the geography, so they are located in between Malaysia and Indonesian straits. It's a group of islands. It is like around 63 islands, and it is highly urbanized with very little primary rainforest, and there is a lot of investment currently going on as well for land reclamation. So I'll just give a brief about how the land reclamation works there. So if you see through the history, initially the total area of Singapore prior to 1960 is around 581 square kilometers. And because of growth in population, because it started becoming an hub, there is a rise in population, and that's where there is a demand and the land area need to be increased. And in 1990, it is 633 square kilometers, and presently it is 714. And what I showed is only the areas which are light or beige in color. So there are other reclamation works which are ongoing. So it is expected around 800 to 900 square kilometers to grow. Again, there are facing some more challenges, and that's why it is getting delayed. If not, by 2025, they are looking at 900 square kilometers of land, and how this need to be defensed. That is the main topic here. So the typical setup there, it's all high-rise buildings because you don't have much land to grow. So that is where it's all, even the residential flats is from 12 to 24. So mostly all are high-rise buildings, and very attractive commercial systems which are very much concentrated near to the coast. That is one of the threat as well. And the what you call the Settled Business District, which is also located very close to the coastal area. And another thing is there are quite a lot of attractive projects, real estate projects, which includes, like, for example, these are all the developments near to the coast and near to the islands, where there are a lot of investment is going on in $1 million context. So how this need to be protected, because all this looks very nice, but when it goes to the worst case scenario, this is the chaotic thing which comes into picture. And in Singapore, residential apartments as well as cars are very expensive, and in case of flooding, and I'm showing the photographs here, the flooding happens at basement level 3, which is supposed to be very low, but well protected. But again, the flooding happens there as well. So imagine the cost Okay, I'm just giving it as an indicative cost, and there are other scenarios as well. So if this happens in central business district where the economy need to be much more productive, but in this case it will not be, because it is not only the flooding, it is also the recovery cost. Okay, so this is what we are looking at as a study. So, looking into the coastline and the coastal types, basically this coastline is being a reclaimed land. So, 80% of the coast is protected by seawalls. And again, it is a low energy coast. And so that's where even the beach parks, which are concentrated near to the coast, don't have much impact on the due to the waves. And the land use pattern, you can see that all the establishments near to the seafront, we have quite a lot of private properties, and whereas the coastal land either protected by structures, and also there is some sort of arrangement to develop a wide buffer zone so that the impact will be less. So you can see that mostly it is parks and open spaces towards the east, as well as in the southeast, as well as in the northeast part. And some places we have commercial business which are concentrated or more planned towards coastal related activities. So this is how the land use land cover is being planned there. And this is the blue map of Singapore, where water is a major issue. And that is where they look into not even a single drop of water need to be wasted there. So there are 14 reservoirs, 32 major rivers, and 7,000 kilometers of waterways. All the drains are converted into some sort of ecozone where it can be used for rainwater harvesting, or converting that into fresh water as well. So this is the setup of the drainage pattern in Singapore. And when you look into carefully the digital elevation model of Singapore, you can see that most of the land lies below 5 meters. So that means quite a lot of impact in terms of flood inundation. And that is what we are looking into carefully. Okay. So now getting into further, like how we can study this or carry out the studies based on coastal characteristics. Another one is the land use pattern around the coast, and also the vulnerability due to sea level rise within a time frame of 100 years for different scenarios. Okay, so each scenario, what will be the type of impact, that what we try to calculate, and then provide that as a vulnerability and inundation map as well. So in terms of methodology, we looked into 0 to 10 meter elevation as a critical part. And this is where geospatial techniques I wanted to a little bit highlight here, because in any country, getting the elevation data is a major challenge. And in Singapore also, we face many challenges, and that's why I put it as sources of elevation data. And then building the terrain model, then comes the land use pattern on top of it. Then 100-year scenario, how it will impact the coastal part of it, and what is the methodology, and how geospatial applications helped in developing the scenario maps. So I have a separate section on this 3D mapping of Singapore, like because it is very difficult to fly a plane other than commercial planes which have a defined route, and it is impossible to fly a plane or any sort of aerial data collection tools over Singapore. So what we, again, I'm talking about 2008 to 2012. Of course, the Singapore Land Department has already carried out a LIDAR survey, and that is much more high resolution. But before that, we didn't had a chance to use any of these techniques. And that is where we tried mostly on terrestrial base, how we can able to effectively collect the data. and try to use satellite sources. Okay, so this is what I'm trying to say, that how we can able to use geospatial techniques even though there is no high resolution data available. What is required and how we can able to generate a decent digital elevation model, provided a decent funding as well. So the good part that when we started the study is the Singapore Land Authority has developed something called Singapore Satellite Positioning Reference Network, which is nothing but survey network where you can able to use real-time kinematic GPS to collect precise data wherever the network is available. Maybe I will show you the map where you can see the reference network covers almost 90% of Singapore, and wherever you are moving with the real-time kinematic rover, you can able to get a X, Y, and Z. So this is what is the plan. So what we thought is we will work with Singapore Land Authority, but in order to measure the what you call terrain model of islands, that is what the challenge is. So what we have done is we funded two of the reference network. That means we bought and then contributed this to the network so that we get free of cost data for all the other network points. So it is like a collaborative approach where we can able to provide some input as an equipment and then try to get data free of cost for this. So this is one approach we adopted, while collecting the data. And what we have done is we used real-time kinematic GPS wherever possible to collect the data using multimodal concepts. And you can able to see that some terrain model has been done based on the points which we generated. And from there, we can able to construct the digital elevation models. The other thing is the drains, because it is very difficult to collect data along the buns of the trains. And that is where we had an opportunity to use a car-mounted LiDAR. So that this helps in terrestrial-based data collection tool. And this we used it for all the roads, so that that is where most of the drains are near to the roads. And when we know the elevation of the road, then we can able to also define the drain, what you call the bunds, so that we can use that for flood modeling. So this is the main idea. This is another mode of data collection. And then, of course, at that time, Worldview 1 launched the what you call panchromatic with the stereo capability, so that we can able to generate terrain model from that. So it is again the good part is it is 0.5 meters, so it helped us a lot. Standard photogrammetry techniques where we collected as much as ground control points, and then from there we done the processing of it in order to generate the digital terrain model. So of course, by default, it gives you the surface model, and from surface model, we train the data set in order to derive the digital elevation model. So we got both the models generated, and from there, we managed to get the what you call the high resolution contours as well. You can see the pink ones are the 5-meter interval contours, which was provided to us as a base map. And what we had done is 1-meter contours, which were generated based on the satellite stereo images. So putting together to generate the high resolution TEM. So we have the conventional survey from GPS, data provided from, like, for example, the 5-meter interval contour provided by agencies, and elevation derived from satellite stereo we put together. And then finally, when we try to come up with RMSE, which ranges from 0.3 to 0.7, which is enough for generating a 1-meter sea level rise, what will be the impact for Singapore. So I just quickly done this for the part of geospatial, role of geospatial in terms of generating the high resolution model. So now we had come up with the coastal terrain so that we can able to classify the elevation with reference to different levels. And this is the map which shows the different levels of map. And what we had done is also, this gives you a first level of indication, like what are all the lands and how much is the percentage. like 0 to 2.5, 2.5 to 5. So when you look into different aspects of it, so we can see how the landform is being arranged with reference to elevation. So this is a good guide for to do a preliminary assessment. So then next thing is how we done the inundation scenarios. So these are all the what you call SRES scenarios: B1, B2, A2, A1, FI. In my earlier slide, I already mentioned that it is B is the best case scenario and A1, FI is the worst case scenario. And these are the second column denotes all the projections of the from the IPCC. And then what we had done is we took into consideration the highest astronomical tide experience at the time. So these two, as well as what is the storm surge experienced as of now. So we are looking at the not as a conservative approach, to look at the maximum level so that we don't miss any of the scenarios. So finally, for each of the climate change scenarios, we came up with the inundation level. So you can see that best case is around 3.08 and A1FI, that is the worst case scenario, is 3.29. So with this, we try to come up with the inundation maps. So again, demonstrating the capability of geospatial techniques, bathtub approach, which is very common. This is very common in FIT, flood information tool, which can be used for generating the first level of what you call inundation maps. So the methodology is defined here. We use a digital elevation model and the scenarios for each of the inundation scenarios of each of the climate change projections, and then we come up with the inundation map. So one is inundation map, another one is water depth map as well. This flood depth map help a lot in terms of developing the risk maps as well. So this also we derived from the digital elevation model and from the scenarios. So if you see, like I projected it for different levels of scenarios. Like for example, it is B1, what is the inundation for 100 years, B2 in 100 years, then A2 and A1, FI. So all those are plotted on a flat map of Singapore. Now I overlaid over the land use land cover. So now you can see that what are all the land use land cover which is being affected because of the sea level rise, which is worst case, which can happen in 100 years from now. So there is a table for it. So you can able to see that different land use patterns, what is the impact. So with this, we can able to come up with the overall, with this, we can come up with the overall view of land use land cover scenarios, and what is the percentage of land loss also being calculated. So the first step in the risk assessment is the percentage of land loss. Then the next one is on developing hazard and risk maps. So what we have done is from the coastline 2 kilometer inland, we have taken it as the study area, so that is considered as the effective inundation. But this vary from area to area and in consultation with terrain as well. So with this, what we have done is we developed a best fit model where we can able to do the hazard and risk map. So we consulted many risk assessment tools. One of that which came into very good best fit is ASSMH, which is developed by Federal Emergency Management Agency of USA. So it is a multi-hazard risk assessment tool. In this case, we used only for flood mapping. So what we learned from FEMA is the most important thing is you need to establish the facility class. So this is based on land use land cover. The next step is to, which we already derived with the flood extent and the flood depth map. And then you need to also develop a risk exposure database, which they have a very good comprehensive data management system. And this can be further customized, which can be further customized for different what you call scenarios. So finally, with this, we can able to come up with the what you call conclusion, where and all, and how the areas need to be inundated and how it can be mitigated. So facility class distribution is very important. So in any what you call disaster scenario, there are two facilities which need to operate to be operational, which is critical. Another one is essential facilities. This was a very good exercise for us in order to group all the facilities and then make sure those facilities are in the location which can be operational. So if we can able to, this is not a complete list of facility distribution, but we can able to customize this further. This can be adapted for any locations, geographical locations. And what we have done is also we developed a risk exposure database so that all this comes in with the proper IDs, and then we can able to add proper elements, and then how the risk can be coded as well. Then we have the flood depth map, and there are models which are available to identify what is the depth damage. That means if there is going to be a 1 meter of flooding, what are all the civil structures or electrical structures or mechanical structures which will get affected. So for that, we consulted different flood loss models which are available in the in different countries like UK, USA, Germany, and Japan. And then we managed to come up with a customized one for Singapore. So there was a formula which has been derived for this. Using that, we can able to calculate what will be the damage based on the flood extent and flood inundation depth. And with this, we can have different scenarios. Along with the return periods, we can able to calculate what will be the cost for it, because the flood depth will also give you the cost, not only the damage, and also the cost for it can be used for generating the economic loss as well. So in this case, presenting the worst case scenario for 100 years, with a written period of 100 years, what will be the economic loss for different land use, land cover things. So this is what we had calculated for different locations, and this is considered as high intensity event. And there are low intensity events also. So the decision makers or practitioners can use this map for planning further in terms of adaptation or mitigation related things. And then also the worst case scenario, because at that time Amsterdam has calculated for 100,000 years, and we also tried to adapt it, which is unlikely scenario, but this will help in any country to prepare for the worst case scenario. So this is the methodology being adapted for developing such maps. So going forward, definitely there is an impact, physical impact of sea level rise in Singapore. In spite of its well-planned environment, there will be permanent land loss and temporary inundation. The most important thing is land use planning need to be taken into consideration when we go for future master plans. And the socioeconomic impact, what will be the what you call consequences when we are planning, that also need to be taken into consideration. The most important thing is how to resist in sacrificing the coastal buffer, even though the coastal buffer is predefined already, but there are temptation in terms of doing it for short-term economic gains. So those things need to be taken into consideration while before proposing any projects. And even a small decision will help a lot in terms of long-term erosion and erosion and inundation plans in the scope of rising sea. So to conclude, the Singapore is well planned, and it has a very little socio-economic impact because of the far-sighted land use planning. But still there are things like looking into short-term economic gains and also infrastructure planning, taking that like extreme event into consideration while planning that. This was the conclusion. What I done is I skipped many things because of the time constraint. There were studies which are carried out even for socioeconomic analysis. Suppose like one person, if it is flooded, even though there are multi-story buildings, even a person couldn't go for work, then there is a loss, socioeconomic loss. So those type of things were also taken into consideration. But because of time frame, I removed some of the slides. And that's all for today. And I'm open for any questions and answers. Thank you.
Sir, thank you so much, sir. And can we wait for 1 minute for participants to source their questions?
Yeah.
Before that, thank you so much, sir, for taking time for us to deliver a training session on the coastal characteristics and land use management in Singapore in the face of its rising sea level.
Thank you. Thank you.
It's very interesting presentation, sir. Actually, it covered all the things related to the climate change.
Thank you. Thank you, Gautam.
Sir, as of now, there is no question, sir.
Yeah.
Sir, Lakshman, sir.
Salute. Thank you, Dr. Kumanandra, sir, for your very informative and interesting presentation. Thank you very much, sir, for sharing your very good research work for our participants. Thank you, sir.
Thank
On
you.
behalf of NIDM and Bharadas University, we convey our sincere thanks to Dr. Kumanandra.
Thank you, Professor Lakshman, and thanks for this opportunity. And thanks for all the participants for taking time to listen to this short briefing. Thank you. Thank you very much. Thank you all.
Sir, thank you, sir.
Thank you.
Lakshman, sir.
Sir.
Shall we conclude the 3 days online training?
Yes, sir. Yes, sir. We can start.
So, dear participants, thank you for all the patience for all 3 days. And with you all, it is possible for this success. Dear participants, this is the end of our 3 days online training program. Before concluding our 3 days online training program sessions, I'd like to convey my sincere thanks to Sri Taj Hassan, IPS UD, and Professor Surya Prakash, our Head GMR Division and CBR Industrial and Cyber DRR Division, NIDM, MHA. And also a special thanks to Dr. Selvam sir, Vice Chancellor, Bharadas University. And also my sincere thanks to Dr. Lakshman sir, Assistant Professor, Department of Geoinformatics, Center for Disaster Management from Bharadas University, for taking the time and arranging the resource persons and arranging the students, coordinating with NIDM. And also my special thanks to all the panel members and participants, and a very special thanks to IT section of NIDM who is working behind the curtains. So, any comments from the Dr. Lakshman sir?
Sir, this is very important. Not only important, also it's a timely program we organized with the support of NIDM. Actually, NIDM, we brought all over India very good eminent researcher. We shared their experience and very good presentation. And, I thank all the participants. More than 290 participants from various departments have registered and participated in this online training program. The participants included undergraduate student, postgraduate, research scholar, even academician, scientist, and policymaker. I would like to convey my sincere thanks to the Executive Director of NIDM, Sri Taj Hassan, and Professor Surya Kumar, the team of NIDM. Especially, my special thanks goes to Gautam Krishna, who is the man behind the training program, successfully organized this program very patiently. Even a lot of technical issues we faced during the presentation at the time. Really, thank you, sir. Thank you very much.
Thank you so much, sir.
My sincere thanks to all the resource person, starting from Surya Prakash sir and Ajit Badam and Srinivas Raju sir, Mr. Jayachandran from Karnataka State Remote Sensing, Mr. Hari Kumar, Harihara Kumar, and Madam Harjeet Kaur, Professor Ganadhi from VIT, Dr. Muthu from French Institute Pondicherry, Dr. Kumanan Raju sir from IIT Madras. Sir, and also I thank all the participants and IT team behind your NIDM. So they are the main reason for success of this
Thank
training.
you, sir.
Thank you, sir. Thank you very much for your support and cooperation. Thank you.
Thank you so much, sir. And also my sincere thanks to you from NIDM and Dr. Salom sir, VC, Bharadas University, and all the students of the Bharadas University to making the program success. So, dear participants, we will meet again in the next week with different programs. So you can register with the NIDM training portal for future programs. On 29th of August, on Monday, we have a program on emergency operation centers, and also a program on 31st August on landslide risk management. So you can register through the NIDM training portal. So thank you for all of you for joining with us. Jai Hind.
Thank you. Jai.
Thank you, sir.